If I told you I have a dozen donuts, you would know that I had 12 donuts. A dozen stands for 12. If I told you I had a dozen bicycles, you would know that I meant I had 12 bicycles. No matter what I'm talking about, if I have a dozen of them, I have 12 of them. When we're dealing with atoms that make up the elements in the periodic table, they're incredibly small. And so even if I have a small handful of carbon, for example, I have lots and lots and lots of atoms. So I'd have many, many, many dozens of atoms. Since there are so many, scientists came up with a new term to indicate this huge number in a very similar fashion that dozen always means 12, and this term is the mole. So if I have a mole of something, I have a huge number of those things. I have 6.02 times 10 to the 23rd of those things. This is a number written in scientific notation. If I take it out of scientific notation, it looks something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. The decimal, which is here in the regular notation, moves 23 places to be after the first digit, 6.02 times 10 to the 23rd. It's a very large number, but it has to be when we're dealing with the atoms because atoms are incredibly small. So 1 mole of any sample of atoms means that I have 6.02 times 10 to the 23rd of those atoms. A mole of boron atoms is 6.02 times 10 to the 23rd. Boron atoms. A mole of sulfur atoms is 6.02 times 10 to the 23rd sulfur atoms. That's an equivalence that I can use to convert from one unit to the other. I might have a unit of a mole and I want to convert to the actual number of atoms, and I would use this equivalence. So let's work a problem. I'm going to write that equivalence up here so that we have it handy. I'm going to write 1 mole of X, because X can be anything, equals 6.02 times 10 to the 23rd of those X's. Usually we're using talking about atoms when we talk about the mole, but we can be talking about bicycles, we can be talking about elephants, we can be talking about pencils. That part doesn't matter. So for example, I might have the question, I have 2.8 moles of titanium atoms. Convert that to actual titanium atoms. So if I have 2.8 moles of titanium, how many atoms of titanium is that? So I have question mark, atoms of titanium. I don't have to write the word atom because if I write the symbol Ti, that means the atom of titanium. But I want to know how many atoms of titanium equals 2.8 moles. Notice I abbreviated mole like this. The word is MOLE. To abbreviate it, you can only go as short as MOL of titanium. And then times in my ratio sign. On the bottom, I'll put the unit mole so that it cancels. On the top, I'll put the unit titanium atoms because that's what I want left over. And I use my equivalence. You might want to have this handy on a piece of paper. The equivalence is 1 mole of X, so 1 mole of titanium is equal to 6.02 times 10 to the 23rd of the titanium atoms. The unit mole cancels, and all I have left to do is punch it in my calculator. Let me do that real quick. 2.8 times 6.02 times 10 to the 23rd. I'll use my EE button or my EXP button on my calculator. I'll round it to 2 sig figs because of the 2.8, and I end up with 1.7 times 10 to the 24th titanium atoms. And so that would be the answer. We also could go backwards. Let me get this out. We can go backwards. For example, the question might be, if I have 4.6 times 10 to the 14th, that's a pretty large number in and of itself, cobalt atoms, How many moles is that? How many moles of cobalt do I have? Again, we set up our unit conversion. We've got the question mark with the moles of cobalt, and we set that equal to 4.6 times 10 to the 14th cobalt atoms, and times and our ratio sign. We always put our units first. We let our units guide our problem, and so we'll put the unit of cobalt atoms on bottom and the unit of moles on top. The numbers come from our equivalents up here. Again, the 1 goes with the mole. The 6.02 times 10 to the 23rd goes with the cobalt atoms. And all that is left, my cobalt atoms cancels, and I'm left with moles of cobalt. And now I have to plug it in. I'll punch in 4.6 EE or EXP14, and then I'll hit divided by, since it's on bottom, 6.02 EXP23 equals, I'll go ahead and round my answer to 2 sig figs. This number, this conversion has 3 sig figs, so I'll go to 2 sig figs, and I'll end up with 7.6 times 10 to the minus 10, 10 to the minus 10, and my unit is moles of cobalt.